welcome back to codezing.org. We're going to do another level 3 project today. This one's going to be Tic Tac Toe versus another human. So later on we'll do versus a computer player, but to start let's do versus human, another human player. So we got codezing.org / tic tac toe _v _human. Or obviously much easier than typing that in is to go to the website codezing.org, level 3 code. Tic Tac Toe versus another human. Like I said, we'll get to versus a computer, but let's start here. So simple enough, it's X's turn. Where do you want to put your piece? And you pick a number that corresponds with the grid, and of course you should always pick the center. And I'll play against myself, and I will let myself win. And then if we go to, where'd it go? 9. Game over, X wins. Alright, so it looks pretty simple. Obviously, Tic-Tac-Toe is a fairly simple game, but you'll see the complexity in making sure that people are entering the right information and providing user feedback and keeping track of where people have placed their pieces and checking every time to see if somebody won. It gets to be a multi-step programming problem and a little more complex than we've seen so far. So you can click at the bottom to view the Python code, or you can just download the file if it's pretty big to copy and paste. If you do choose to download, it'll give you a little warning probably, because it is obviously a file with a program in it, and you could write malicious code in a Python file. Obviously this one is just tic-tac-toe, but you can click keep if you want to save it and then open it in Spider, or obviously you can always just click view, and you can see this one's pretty long. So we'll copy all that and head over to Spider like always and paste that in. And so we've got a pretty complex thing here. So first thing you'll notice that's different than anything we've done before is this def piece, and you can see we have a few defs in here, and those stand for defined functions. And so we've created kind of multiple functions to run within the game. So let's start looking through those functions. So a function is just kind of like a little bit of mini code, or like a program within a program. So you can see this first one just displays the board. And that's the only thing this job. It's a series of print statements, and that's how we get the nice, X and then a vertical line, and O, or the number of the space, a vertical line, and then separated by some just a dashed line across the next row of the board, dashed line in the next row. So if we were to just run display board, so to run a defined function like that, you just type in display board, and we're going to have to pass the board, which we haven't created. So we won't actually be able to run that independently, I don't think, unless here's the board variable that it's looking for. So in the defined function, you can see that it's requesting the variable board from somewhere else. So display board receives the variable board when it's called and then prints it out. So we're going to need the variable board created. So it's just a list of 1 through 9, and then it can display the board. So if we just ran that piece of code, and we don't want to actually play the game, so we'll comment out that function call. Now let's run this. It should just print the board. Okay, then it did. It printed out the 0th item in the Python list, which is 1, and then the vertical line, and then the first item in the Python list, which is 2. If you remember, Python lists are ordered starting at 0. So this is the 0th item, the first item, the second item. That's where these numbers come from in the board. Alright, so it's just kind of a mini, every time we make this call, display board, and we pass it the variable board, it'll print out the board. That's what this little piece of code does. And whenever we call display board, that's what it'll do. So the next function that we've defined here is place piece. So probably guess what that does. It asks the player where they want to put their piece, and then it puts it in the right place. Actually, this one returns the choice that the player made. So in our function place piece, we are going to print out the board. So this is right before you ask the user, so you got to show them the current board. And then what it's going to do is loop through the current board and figure out which spaces have already been used. So acceptable answers is going to contain a list of all of the choices that a player can do, the ones that are acceptable. So if there's an X in number 1 is not acceptable, so it won't append it. So this creates an empty Python list, and then it loops through for each place in board, right? And board is just going to be a Python list. So look through the Python list, and if the type of place, right, so it's going to look at the variable place and look to the type, the Python variable type for place. If that is equal to int, then append that to the acceptable answers list. So let's think through if the Python type for place is int, then append it to the acceptable answers. So when would it be int? Those would be times when the spot has not been chosen already. So if the list contains 1 or 2 or 3 or 4, then it will append it because the type of that is going to be equal to an int because they're integers. When wouldn't it be an integer is when it's been taken already. So if it is an X or an O, those are text, they're strings. The Python type for those would be string, not int, and it won't append them. So when you first start the game, the acceptable answers are all of them, 1 through 9. But as we play the game, you'll see that the acceptable answers list gets shorter and shorter until, as you approach the last couple moves, maybe you only have 1 or 2 items in the acceptable answers list. And now we are going to try to loop through what the player's choice will be. So we're going to start out with the placement choice of none, because they haven't made a choice yet. And we're going to create this loop that is querying from the player where they would like to put their piece, checking whether that is an acceptable choice, and if not, giving them feedback to choose again. So this loop is trying to check to see that the player hasn't entered any punctuation or letters or values that are not valid for them to input. So it's going to continue looping through until they make an acceptable answer. So it's going to ask them, select an input choice. If they type a number, right, it'll check, is the placement choice an integer? Or it'll try to set it equal to an integer. If they would have typed the letter A, then that will produce an error, and you'll end up in this accept code. This is not an acceptable answer. So let's try to run that little bit of code again. So let's bring our board variable back, and let's run place piece board, and then let's just run that. Let's see what this function is all about. So we can see, where would you like to place your piece? Right. So it ran display board, which is our first function. It printed out the board for us. And then it's going to run through the next step. So it's created acceptable answers, and I guess we could have printed that out so you can see. But it would just, since there aren't any places that are taken so far, it'd be a Python list, the same as board. It'd have all the integers 1 through 9, and it has set placement choice to none, and now it's at this step. Where would you like to place your piece? And let's say I enter A, right, which is not a valid choice. Let's see what it does. It tries to set placement choice equal to an integer, and since it's a string, it can't do that. The code fails, and it ends up running the accept code, which is that is not an acceptable answer, please choose again. Since this is all in the while loop, it will continue running until placement choice is in acceptable answers. So it says, while placement choice is not in the acceptable answers, keep doing this. So until somebody gives you a valid answer, keep running this loop over and over and over until you get a valid answer. So if I put in, exclamation point, or I put in, gibberish, or I put in lots of numbers, well, placement choice not in acceptable answers. Oh, it didn't print out any feedback for that because it didn't fail, but obviously you can see it didn't like that answer. So maybe that's a little bit of a bug. Somebody you could add. So I put in something that's not in acceptable answers, but it is an integer. So it didn't run the accept code. Right? It didn't run this because it was able to set that to an integer, but it also knows that that's not an acceptable answer. So it's asking me again, where would you like to place your piece? We could put in like an if placement choice not in acceptable answers, print. We can just print that again. And then we can have a bare accept, I guess. So now accept print. We just print out a blank. We're unhappy with invalid syntax. If placement choice is not in acceptable answers. Oh, I accidentally copied over that print statement. Okay, now it should be happy. All right, and let's kill that one that was running, or I guess I could just give it a valid choice there. Okay, so I aborted everything. Let's run that again and take a name acceptable answers. Where's that? Line 16. It doesn't like print acceptable. Oh, answer. It should be answers. Great. Alright, so it displayed the board like we wanted it to. It has now printed the acceptable answers, and since nothing has been chosen, it prints the full list. And it's asking us where we like to place our piece. And we saw that if I print letters, it'll say that's not right. If I print symbols, it'll say that's not right. If I print now a long string, or a long int that's not in the group, now it also says that's not an acceptable answer. So I think we fixed one of those little bugs that we found. And so until you enter 1 through 9, it's going to keep asking you. And once you give it an acceptable answer, it finishes this function and returns to the user placement choice. So if we wanted to actually get the placement choice equals place piece board. So it's going to run the place piece function up here, and it's going to take this, whatever's returned from that function is going to come here. So placement choice equals run the function and give me back what it returns, right? Meaning it returns this to the caller of the function. So if I did that and then I printed out print placement choice, you can see that I can call this function. It will run the code. Where do I want to place my piece? Let's say 3, and it will print out the placement choice. So now I can call that function from another place in the code, and it will return placement choice for me. Alright, so 2 functions down. We got display the board, and we have placing the piece on the board, the user loop to try to get the placement choice from them. Now we have a further function. This function will check to see if the board contains a win. So first of all, this one took a little bit of doing. There's probably a much simpler way to kind of loop through and see if this is right, but this explicitly checks every single possible tic-tac-toe. And with a board of only 9 squares, there weren't that many choices, so I just did it explicitly of what is every single winning pattern. Right, you could have the 0th, first, and second items. And this is written a little tricky just because the list placement positions aren't exactly, they're one less than the actual displayed value. Just because this is the 0th item, this is the first item, and the second item in the list. But it looks through every combination. So this is win across. The next 1, 3, 4, 5 is win across the middle. Then win across the lower. The 0, 3, 6 is this, the vertical win, the next vertical win, the next vertical win, and then at the end the two diagonal wins, so 0, 4, 8, and 2, 4, 6. So those are all the winning patterns that are possible. And then I set X wins and O wins to false, and that there is a tic-tac-toe to false. And then it's going to check through, so it's going to receive the board, and it's going to look through every possible combination. So if 0, 1, and 2 are all X, so there'd be these top 3. If these top 3 are all X, then X wins equals true. So switching it from false to true. It's checking every combination all the way through, and then it gets to the end and says if X wins or O wins, then there was a tic-tac-toe. And it's sending back to the caller those variables. Is there tic-tac-toe, true or false? Did X win, true or false? And did O win, true or false? So that's what that function does. And I made a separate function for check for a tie. You could probably include that up here if you wanted, but I made it a separate function, and it's going to look at the board. It does kind of the same thing. Is the tie game true? Or it sets tie game equal to true at the beginning, and it loops through every place in the board, and if it finds any of these places are not X or O, then tie game equals false. So we're going to test, is the tie game true or false? We look through every item in the board list. If any of them are not taken, meaning if they're still an integer, they're not an X or an O, then it makes tie game equal to false. The final function that we have, now that we've written all of these others, printing the board, placing the piece on the board, checking for wins, checking for ties, now we're going to actually play the game. So this final function will do the playing, taking turns back and forth, placing pieces, and then checking for wins using our other functions. So this first section just defines the X player and the Y player as human 1 and human 2. I think in the versus computer version, you'll see that one of these will be set to computer, but I left those in there for this version as well. So it sets X player to human, Y player to human 2, and then creates a starting board that has all of the spots as integers. It sets game over to false and starts with X, who is the first player in tic-tac-toe. To play the game, we have a while loop, which we've seen in several of the other games, and it'll loop through until game over is while game over is false, it will loop through. So once we do find a win, you can see down here, game over will be set to true when there is a win or a tie, and it'll stop the while loop. So if the current player equals X, we're going to call the place a piece function from above and get their placement choice, and then we're going to set the board list equal to X in that spot. The same thing if the current player is O, we're going to let O place a piece on the board, and once the piece has been placed by either X or O, depending on whose turn it is, it's going to check for a win, and it's going to check for a tie, which makes sense. You let a player place a piece, and then you check for a win, check for a tie. If there is a tic-tac-toe, right, so if it checks for a win and tic-tac-toe comes back true, then game over needs to be true, which stops the loop. It stops the game from continuing to play. We want to print out the game, which is our display board function from above. And then we also want to add to that, if X wins equals true, then print X wins. If O wins is true, then O wins. So that all seems pretty straightforward. If there's a tic-tac-toe, stop the game, print the board, and then print who actually won, the X or the O. If the game is a tie, comes back true, and tic-tac-toe is false, that means, so if it ends up being a tie game, and there was not a tic-tac-toe by anybody, then display the board to the screen, set game over equals true, so the game stops running, and print tie game. And if none of these happen, right, if tic-tac-toe is not true and the tie game is not true, it will end up coming down to this value, and it will change the current player from X to O. So if the current player is X, switch it to O. If it wasn't X, that means else. So if it's not X, then it has to be O, then make the current player X. So this little piece of code at the bottom changes the player from X to O. So if there wasn't a tie or a win, it'll switch the player and then start back at the top. Let the X or the O place a piece, check for a tic-tac-toe, check for a tie. If there is one, print out the win. If not, then let's play again. So a lot of stuff going on. I kind of broke this one into pieces, which more complex games you'll see for sure as you write more code. They'll be broken into steps, into little functions. You'll need to write each function, and then once the game starts, you can see it's a little easier to understand what's going on in the game. You can imagine if I had appended all of this, all these small functions, into one long function, it would get a little hard to read, hard to figure out for somebody who's trying to look at your code. So breaking it into chunks helps the person read what's going on. Oh, you're just placing a piece on the board in this step, and I know what that function did because I looked at it earlier, instead of seeing that entire code repeated down here. So we'll just play one time just to make sure it's running. So we got the board where I like my piece. It's going to be 5, and you can see now it has moved the space 5, converted that into a string X, and prints the board for us. And it successfully changed the user back to O, and let O place a piece, and it'll go back and forth. Let's see what happens if I can make a tie here. 6, 7, oops, I accidentally won. Alright, I couldn't even force a tie. So it found a tic-tac-toe for X and prints X wins. So kind of cool. And if we actually do, will this result in a tie? If I, X wins again. What am I doing? All right, 1, 2, 3, 4, 5, 6, 8, 7. Oh no, I'm gonna win again. How am I not able to get a tie game? 1, 2, 3, 4, 6, 5 there, 7, 8, that'll make a win, 9, 8, there we go. Alright, I finally was able to get a tie game. Alright, so if all the squares are filled and nobody gets a tic-tac-toe, we do get a tie game as we expected. So, much more complex, several different chunks. The important part being, can you read the code? Can you understand in general what's happening? Don't focus so much on what every single step is doing, but you understand there's while loops and their purpose, the if statements and what they're doing, and the fact that we now have broken into several smaller functions that we can call in the bigger game. So getting more complex, building cooler stuff, I think, and we'll keep adding to it. So if you have any questions, add them to the comments at the bottom of the video or email info@codezing.org. But keep at it, stick with it. Watch the videos a few times over if you need, and try stuff. Change the values and run it and see what happens. But have fun exploring and coding.